Hello YouTube. Today we're going to take a look at how to assemble the ToAuto 3D printer. The goal of this method of assembly is to end up with the printer frame sitting squarely without tension or torque on it. This will allow us to achieve beautiful, precise prints. First, we need to unbox our new printer. Take a few minutes to check your parts are in good condition and the quantity of them matches the bill of materials in the assembly manual. Take the pre-assembled printer base and place it on a flat, level surface with plenty of room around it. You'll need to grab two vertical Z-gantry columns. These are mounted on either side of the printer with a total of 4 screws that are inserted from the bottom. I recommend starting all of the screws by hand, so you can make sure that they do not cross-thread. You may need to carefully tilt the printer body to have an easier time starting the screws. Ensure the Z-gantry screws are snug. Do not over-tighten, as these are aluminum threads and they will strip out from excessive force. Next, we'll take a look at the X-gantry. You have one guide wheel bracket that holds the X-axis stepper motor, as well as one that serves as an idler. The wheel brackets are held down by 2 screws on either end. I found it easiest to place the screws into the guide wheel brackets before snugging them up with a hex key. You do not need to tighten them fully at this stage. Later, we will look at how to ensure the gantry assembly sits square to the printer frame. Be sure to place the extruder head on the gantry before attaching both guide wheel brackets. When we place the belt on the X-gantry, it needs to lay in the channel on top of the guide rail, passing beneath the top guide wheels and fitting into a thin slot on the stamped metal extruder head frame. I found that one of the crimped brass ends of the belt was able to nicely fit under both guide wheels. You can also lay the belt beneath the wheels before sliding the extruder head onto the guide rail. You want to be careful not to damage the surface of the wheels or the grooves the wheels travel in. We also need to install the X-axis belt tensioner idler assembly. This is mounted on the end of the guide rail on the side of the idler guide wheel bracket. Each end of the belt needs to wrap around the X-axis stepper motor and idler pulley. When properly tensioned, the belt should be taut without slop. Slop in the belt will cause backlash whenever the extruder head changes directions. Backlash is how far the belt or lead screw of an axis can turn or move before the tool head actually moves. In this case, the tool head is our extruder nozzle. However, having the belt too tight will cause excessive bearing wear and possibly belt stretching. Finally, install the timing belt pulley cover. It sits over the X-axis stepper side of the assembly. Next, you will take the X-gantry assembly and slide it down onto the vertical gantry members. Then, take the top gantry support and snug it down to the vertical gantry members. You will notice I lift the X-gantry up before snugging these screws down. This helps to ensure the vertical members are spaced properly at the top and will not cause excess strain on the guide wheels or Z-steppers. Then, I lower the X-gantry down to the bottom, where I loosen and then retighten the screws at the base of the vertical members for the same reason. Grab your Z-axis stepper motors and their respective mounting screws. These are placed on either side of the printer frame in this orientation. The trick here is to get them sitting straight and flush to the frame so they do not impart torque or bending to the Z-axis trapezoidal lead screws. I had to loosen the power supply cover and slide it out of the way slightly on the base to get this side to sit down flat on the printer's frame. Next, we move on to the trapezoidal lead screws for the Z-axis. First, we need to install the pillow block bearings at the top of the Z-gantry. Then we insert the Z lead axis screws down through the pillow block bearings, thread them through the brass lead screw nuts in the X-axis gantry, and finally, we seat the Z lead axis screws into the anti-backlash coupling, being sure that the screws do not touch the stepper motor shafts. We seat the lead screws in place by tightening the set screw in the anti-backlash coupling. The purpose of an anti-backlash coupling is to prevent the transfer of vibration from sudden movement of the stepper motor to the lead screw. This improves print quality and accuracy. We need to check a few things to make sure that we're assembling the frame with as little torque as possible. First, with the X-gantry approximately in the middle, measure the gap between both vertical members on the top, middle, and bottom. Make sure it is the same distance apart at each of these points. Now we will finish tightening our X-gantry assembly. What I'm doing here is lifting the X-axis gantry to the top of the lead screws, making sure the X-gantry assembly screws are snug but not tight. As you move each side independently, you can see the angle of the X-gantry cross member shift in relation to the guide rollers. You want both sides to be as even as possible, sitting straight on the vertical gantry members. Then you can snug down the two exposed screws before carefully lifting the assembly off to tighten the screws obscured by the vertical gantry members. Then we need to reinstall the top gantry support with the X-gantry assembly at the top of its travel for proper spacing. You will need to loosen the Z lead screw pillow block bearings mounting screws and allow them to find their place. This is to prevent bending and torque on the Z lead screws. Mine ended up sticking out past the end of the top printer frame, so I did not use the snap-in end caps. Next, I used two of the angular support arms as spacers to reference the X-axis gantry off of the printer base, loosening and retightening the exposed X-gantry screws to further ensure it is sitting straight and even. We want to make sure the guide wheel shafts are not too tight on the assembly. This can cause the guide wheels to pull to one side, creating uneven force on the wheel's two critical surfaces. We want it to just be loose enough that you can turn the shaft with a hex key with moderate force. Using the supplied wrench, I then turn the eccentric nuts on the X-gantry guide rollers located on the inner wheels. An eccentric nut is one that does not have its rotational axis or shaft centered in its shape. This allows us to adjust the tension of the guide wheels. The goal is to adjust them so that all 6 of the X-axis guide wheels have the same tension. You should be able to spin them with some force, but they should not freely or loosely spin. Having the wheels tensioned too tightly will cause dragging and excessive bearing wear. Then we will do the same thing on the 3 eccentric nuts located on the printer bed guide rollers. We will repeat this process once more after we get further into the printer assembly. If you are unable to get a particular set of wheels to adjust evenly with the others, it is likely due to one of the guide wheel shafts being too tight. Now we will assemble the angular support arms. The L-shaped brackets are mounted to the top of the printer and the straight ones go on the bottom frame. You may notice I loosened the screws on the support feet slightly to give the angle bracket mounts a chance to screw down flush and snug to the frame. On either end of the angular support arms is a small tie rod style linkage member. The length of the support arm can be adjusted by turning either end of this. I recommend splitting the difference of any excess thread protruding from the support arm on the top and bottom sides. The key is that you do not want to apply any torque or strain to the printer frame when installing these. You want them to sit neutrally and snug them down. This will also help with print quality and accuracy. Do not forget to snug your support feet screws back down after you tighten down your angular support arm brackets. Take your filament spool holder and mount it with the supplied screws to the top gantry support. Now we will connect the wires. They are labeled. There is one for each Z homing limit switch and each Z stepper motor. Now we can finally turn our printer on. Before the first homing of the machine, make sure it will go down and stop on the homing switches without pressing down on the bed. Let's take a close-up look at a few nozzle tips. One of the keys to a good quality print is using a quality nozzle. You want a round and smooth orifice. Under magnification, you can see that the supplied nozzle's hole is not perfectly round. The second picture is of an E3D brass nozzle. You can see the finish of the nozzle orifice is smooth and the hole is nice and round. Both of these nozzles use the standard M6x1 threads. When changing a nozzle on a 3D printer, you want the hot end to be heated up. Otherwise, any previously melted plastic in the chamber will act like glue and require excessive, potentially damaging force to remove the nozzle. The same thing goes for when you install a new nozzle. You want the hot end up to temperature so you can seat the nozzle firmly against the heat break inside the heater block. This prevents filament leakage during printing. If you ever see plastic leaking from somewhere on your hot end block and dripping down, the nozzle being installed loosely is the likely cause. Be careful not to burn yourself. The reason I did not is because this nozzle change was done before ever inserting filament into the extruder. You can see my silicone hot end sock is a bit too long, sitting too close to the end of the nozzle. I used the supplied flush wire cutters to trim it slightly. Now we will adjust the eccentric nut on the extruder head, making sure that all of the guide wheels have an even tension and do not spin freely, but slip with some applied rotational force. If you are unable to achieve even tension across all three wheels, you may need to loosen the guide roller shaft on the extruder assembly slightly. If it is too tight, it will pull the guide wheel over to one side of the groove with increased pressure. You want the wheel to sit in the center of the guide groove with even pressure on both sides. We can finally install our first spool of filament. Loosen the filament runout sensor guide and make sure the filament feeds straight down into the top of the extruder without any misalignment. Then retighten the screws. We will need to adjust our extruder's tension. On this machine, I set it as low as the design would allow. You want it to securely hold the filament so you cannot spin the extruder wheel without moving the filament. However, you want to do this with as little pressure as possible. When carefully inspected, you should see small grooves on previously inserted filament left by the extruder's serrated feeding wheel. Let's navigate into the preheat menu and turn the bed to 60, and then the extruder to 205 degrees Celsius. After the extruder has reached temperature, you can gently pull the extruder tensioner back and manually feed in the filament. To test the proper function of this, go into the Move Printer menu, select the extruder stepper, and have it feed in 30 millimeters of filament. As the filament extrudes, you will want to watch it just below the nozzle and ensure it is coming out in a straight and even line. If it bends off in any direction other than straight down, this means you have an unevenly shaped nozzle orifice, or the nozzle orifice is dirty or partially clogged. Now we will do the final guide wheel tension adjustment. First, I want to even out the Y-axis guide rollers. I take a hex key and one of the supplied wrenches and slightly loosen all of the guide wheel shaft nuts so the guide wheels can find the center of their grooves. Then, using the supplied wrench, you can adjust the 3 eccentric nuts to get an even wheel tension. Be sure to move the printer bed back and forth as you do this so the tension is averaged out over the bed's length of travel. Next, we'll move on to some cable management. I have a variety pack of zip ties here, and I use them to hold the main cable onto one of the angular support guides before providing some strain relief where the cables enter the printer head. I provide strain relief by zip tying the cable to the filament guide on top of the printer head. Now, we'll use a pair of dial calipers or a similar measuring device to make sure that both sides of the X-gantry are spaced evenly from the base of the printer frame when the machine is in its home position. To adjust these heights, loosen the Z-limit switch screws slightly so the switch can be moved down until both sides are at an equal height. A little goes a long way here. It may take some time, but just be patient. Now that our X-gantry is sitting level relevant to the printer frame, it is time to level our print bed. First, you want to make sure that your hot end and your heated bed are up to the temperature you will most often print at. For PLA, I like to use 210 degrees Celsius on the extruder and 60 degrees Celsius on the bed. This printer has a leveling assistance option built into the menu that will jog the printer head to the corners of the bed for you. Grab a small piece of fresh, normal printer paper. We will use this as our feeler gauge. There are 4 large knobs under each corner of the bed to adjust the position of the print bed. You'll want to move to opposite corners in an X shape while you're leveling the bed. It may take a few tries. What you want to end up with is a snug feeling between the paper and the printer bed, where you can still slide the paper without it binding. You will want all 4 corners of the bed to have as even of tension as possible. This will ensure a nice smooth first layer and a proper bed adhesion for your print. Now we are ready for our first test print. I printed a benchy model from Thingiverse, as it is a popular test model to compare the performance between different printers. I will describe the settings I used for this print in the video description. When the print is complete, please allow 10 to 20 minutes for the print bed to cool back to room temperature. This will utilize the benefits of this print bed coating, with prints often effortlessly popping off. If you try to remove them while the bed is still hot, they will often still be stuck to it. This may result in damage to the print bed surface. This benchy model was printed without supports. You can see the printer did a nice job replicating fine detail, avoiding stringing and bridging. Our new printer is set up and ready to start printing. Thanks for watching. If you enjoyed this video, please like and subscribe below.